Hey, we're going to work some derivatives here. All of these are power rules with the chain rule involved. So remember that when we have a power rule, the power comes out front and then reduces by 1. But with the chain rule, that means that we may have a little bit extra on the outside from the inside not being just a single variable. But let's see that in work. So the first one is y equals the quantity 2x plus 1 all raised to the negative 1. So in that case, we're going to look inside here, and what we see is that there's just something a little bit more complicated inside this function than the normal power rule. So I'm going to call that thing inside u. And in that case, I'll be able to apply the power rule just as is. So what I can do is I can treat it like x raised to the negative 1, which means a negative 1 would pop outside. There would be an x inside, but right now that's a little bit different. The negative 1 goes down to negative 2. Now the fact that I've got that u inside there, I'm going to replace it, and I'm going to put the derivative of u on the outside. Okay? So if my u equals 2x plus 1, then my u prime, the derivative, equals 2. So inside my function, I'll put 2x plus 1, that's the u, and on the outside there'll be 2. So if you do want to clean that up again, you would have y prime equals negative 2 times 2x plus 1 to the negative 2. And that would be your final answer. Sorry, I should have left more room there. Messy. All right. Let's do this other one over here. It's y equals the quantity of 2x cubed minus 9x plus 12, and that's raised to the negative 2/3. So in that case, once again, there's something inside there that we'll just call u. And if u is 2x cubed minus 9x plus 12, then the u prime will be 6x squared minus 9. So I'm just going to jump to the derivative. It would be y equals. I'm applying the power rule, so the negative 2/3 comes out front. I'm going to leave a placeholder here for my u. The negative 2/3 goes down to negative 5/3. So inside the function there'll be a u, and on the outside there'll be a u prime. And we can clean that up as needed. But inside we will have the regular 2x cubed minus 9x plus 12. And on the outside we'll have 6x minus 9. Okay. The next one I have is y equals 1 over the fraction x cubed plus x squared plus x plus 1. This can be worked using a quotient rule. But we can also bring this whole thing up as one big unit, and it would be x cubed plus x squared plus x plus 1 to the negative 1. So you have a couple options here. But in the same sense, we've got something raised to a power, so that something inside there will be our u. So u is x cubed plus x squared plus x plus 1. And it means u prime will be 3x squared plus 2x plus 1. So when we do our derivative, we'll have y prime equals, sorry, that was y prime up here too. So doing a power rule, so negative 1 comes out front, so I'll just put a negative. Parentheses for the placeholder that u is going to go in. Negative 1 goes down to negative 2. So in here I will have u, and on the outside I will tack on u prime. So I'll have negative times the quantity of x cubed plus x squared plus x plus 1 all raised to the negative 2 times the quantity 3x squared plus 2x plus 1. Okay. The last example here is the cube root of 4x minus 1 raised to the 4th. So let's rewrite that using an exponent. So it'll be 4x minus 1, the quantity, raised to the 4/3. So we have the same situation. We have something raised to a power. It's more complicated than x, so we'll call it u. Okay, so that'll be my u. Hello, Mr. Penn. Yes. So my u is 4x minus 1. My u prime, the derivative of that will just be 4. So derivative y prime equals, okay, something to the 4/3. The 4/3 will come out front. The exponent will go down to 1/3. And inside there will be u, and on the outside there will be u prime. So inside there will be 4x minus 1, and on the outside there will be 4. Now I don't see any reason you need to clean that up, but if you do, you could definitely multiply the 4 and the 4/3 out front. So you could have y equals 16/3, and that would be times the quantity of 4x minus 1 to the 1/3, or you could turn that back into a cube root if you liked. But going back through these, make sure you understand how we applied the chain rule with that power rule. All right, thank you.